Okay. So can you hear me? Pritham, can you hear me? Hello,
Yes, sir. Yes,
Siddhi.
sir.
Yeah.
Yes, sir. Yes.
So what I was telling that if something is fake, something is false, then why do we study that? Why it has to? Why it was important? Why it is important to study it now? And if at all this is not important, then if it is required, then why didn't we study before? Why didn't you study in the before? We are almost on the flag end of the chapter, almost 70%, 80% we are done. Then why didn't we study? Why don't we study before? And if at all we didn't study, why? When is it? When it is applicable? When this force is applicable? We have to study that. So till now we have done a lot of problems, pulley problems, normal reaction problem, inclined plane problem, spring problem. So many problems we have done. It's all we are able to solve problems, and in all the problems Newton's laws were applicable. Yes or no? Newton's laws were applicable. Then why pseudo force is important? Pseudo force is important because there is a change that it depend on where we see the things happening. Like if there is a pulley, and there are two masses which are, one mass is heavier mass going down and this mass is going up, then probably this is related to the observer. It is the observer, and if the observer is at rest, then we were able to solve. And this type of is called reference. Reference. Since the observer is at rest, we say it is an inertial reference. So basically, the Newton's law is very much clear when things are at rest, when the observer at rest. It will not apply, or rather, it will be invalid for when observer is in motion, or when observer has a acceleration, or acceleration not equal to 0. To more specific, if I say that pseudo force will be required when the observer has acceleration not equal to 0. That means if observer is at a is 0, can have two conditions. One is the velocity can be constant, or velocity can be 0. Yes or no?
So your voice is breaking, sir, fully. Everything
Yeah.
got stuck, sir.
1 minute, 1 minute. I will change to yeah. I changed to my normal this thing. Now it's fine. Now it's fine. Is it fine
Yes, sir.
now? Okay. So that what I was saying that your pseudo force will be required if the observer has a acceleration not equal to 0. Pseudo force will not be required when acceleration is equal to 0, and acceleration is equal to 0 can because of two conditions. One is either the velocity of the observer is constant, or the velocity of the observer is 0. Yes or no? Yes or no? Why? Because acceleration is nothing but change in velocity per unit time. When velocity is 0, obviously acceleration is 0. Or if the velocity is constant, then what is dv by dt? That also equal to 0. That means till now we were seeing all the problems where the observer is having a is equal to 0, or either the velocity was constant or the velocity was equal to 0. That is why the pseudo force was not important. But now we are coming to a situation where that observer is no more having a constant velocity or having velocity equal to 0. Rather, it is having a velocity which is changing at every instant. Either the direction might change, or maybe the magnitude might be changing. Clear? Yes or no? Pritam,
Yes, sir.
Siddhi, you're able to understand?
हाँ सर.
Laksh.
Yes, sir.
Okay. So pseudo force is important whenever there is observer. That means if let's take an example. You have a car. You have a car. Okay, not a car. Let us take a object. There is an object, and it is just lying. So obviously the object having a mass, this will exert a mg force downwards. Obviously the ground will exert a normal force upward. So n is equal to mg. Yes or no? There is a person. This is Laksh. This is Siddhi. This is Laksh, and here it is Pritam. Laksh is at rest. Laksh is sitting on a chair and watching. This person, okay, Siddhi, is moving at a constant velocity, some 2 meter per second. Pritam is moving Pritam is moving like a snake. It is moving like a snake. That means at each point of time, the direction is changing. That means the velocity is what? Not constant. Now, for this three-person observer, this is observer 1, this is observer 2, this is observer 3. We will see what is the force and what is the acceleration. So first observer, then F net, what is net force? Okay, and then we'll see F net is equal to M into A. Okay. Guys, able to understand? Guys, able to understand till
Yes,
now?
sir.
Okay. So see, first, now mass is lying on a ground. Okay. So now you know that n equal to mg. When n equal to mg, the F net is what? Net force. It is 0. So for Laksh, the net force is 0. That means there is no force. Obviously, when net force is 0, there is no acceleration. So F net also is 0. That means your F net is 0. That is equal to m into 0. This is A. This is A. Okay. A is 0. So F net also is 0. But what about Siddhi? Siddhi is also seeing a constant velocity. That means for Siddhi also F net is 0. Why? Because mass is there, but acceleration is again 0. Why? Because Siddhi is moving at a constant velocity. So dv by dt is again 0. But what about Pritam? Pritam, the acceleration, Pritam is moving at a, let's say, acceleration something AP. Okay, let the acceleration be AP. If Pritam is moving at acceleration AP, it will appear that this object is moving at a velocity AP in this direction. In this direction. If this has an acceleration AP, but the net force is still 0, because the net force is 0, n equal to mg. But here m into a is equal to 0. That means it is invalid. A is having a value, m is also value, but the net force is 0. That means there is something problem here. That means the Newton's law is failing here. If m is a value, a is a value, but how come m cross a is equal to 0? Is it possible? Is it possible, Pritam? When you have a m and you have a, is it possible that m into a can be 0?
No, sir.
Then what happened? Why it is not applicable? Because all was fine till here, because the acceleration of the observer is 0 here, because here also observer is 0, here also observer is 0, a is 0. Why? Because when v is equal to 0, obviously a is 0. When v is constant, then your dv by dt is 0, because when the velocity is not changing, obviously the acceleration will become 0. But there was a problem here, because the observer is not a, it is changing. That means the acceleration is no more 0. So in this type of reference, are called non-inertial reference. Are called what? Are called what? Non-inertial reference. Clear? Clear, guys? Pritam,
Yes, sir.
Siddhi, clear?
Yes, sir.
Okay. So when the acceleration, when the observer acceleration is no more zero, those type of reference point are like we studied. No, we studied like in relative velocity when two cars are moving in same speed. Okay, so obviously this will appear rest with respect to this. This will appear rest with respect to this because the reference point. But similarly, you have one more person standing here. This will, for him it will appear that it is moving at a velocity, at a some speed, because it is a reference point. It is a depend on where you see. So till now all the problems were done here where acceleration was zero, but now we are going that we are changing our reference point, that no more the acceleration is zero, it acceleration is no more, the acceleration is not equal to sorry, I mean to say, till now we are seeing where acceleration is zero, we are seeing now where the observer acceleration is no more zero, it is having a value. So whenever this type of problems are there where there is a non-inertial frame of reference, that time the concept of pseudo force come into picture. Understood? That there the requirement of pseudo force come into picture. Then what is pseudo force? So pseudo force, write down pseudo force R is a imaginary force. It's a imaginary force applicable only when observer is in non-inertial frame of reference. Clear? When observer is at non-inertial frame of reference. Second point, observer acceleration is not equal to zero. Clear? Clear? Yes? Are you writing, guys?
Yes, sir.
Okay. Next point. Next is what? What is pseudo force equal to? The pseudo force will be equal to minus ma. Why? I will explain. So we saw an example that this mass was there and Pritam is standing here. So which mass, whose acceleration? So this is acceleration of our observer and the mass of the object, and it is the opposite direction. If the observer is going in this direction, pseudo force is applicable in this direction. So pseudo force is applicable opposite to the direction of the observer. If the observer is going in this direction, it is opposite direction. Second point, it will take the mass of the object but the acceleration of the observer, because this is at rest. So acceleration of the observer will be taken. So if it is going at 10 meter per second square and this is something like 10 kg, then your pseudo force will depend on what? 10 into 10, 100 Newton. And which direction? This direction. Clear? Pritam, clear?
Sir, can you explain this again, sir, this part alone?
So I am asking what is pseudo force. So pseudo force basically imaginary force. It will only come into existence, or we will have the need to use it only when the observer is in non-inertial frame. When I say what is observer in non-inertial frame, it means that acceleration of the observer is not equal to zero. Clear? Till now clear? Okay. When you say acceleration of observer is not equal to zero, it means what? It means that the velocity is continuously changing. You are no more. So acceleration is equal to zero and acceleration not equal to zero. When we say acceleration equal to zero, it means that velocity is zero or velocity is constant. Clear? Yes or no? And when you say acceleration not equal to zero, it means what? Velocity is variable. So this is called non-inertial frame of reference, and this is called inertial frame of reference. So till now, all the problems we are doing in inertial frame of reference. That is why FP was not required. Was not required. Moment we come here in this frame of reference, you will not need. You will have the need of using the pseudo force to make the Newton's law applicable or valid. If you do not use FP, then your Newton's laws will become invalid. And largely we are talking about the second law, F equal to ma, the second law of Newton, which will not be applicable. Clear till now? Everybody clear? Say yes.
Yes, sir.
Okay. So now when we say that what is pseudo force, that pseudo force is an opposite force, it will apply to the observer direction, opposite to the observer direction. If the observer is moving towards the object like this, then pseudo force is opposite. Second point. What is it equal to? It is equal to minus ma. Minus means it is this direction. And what is m? The mass of the object and the acceleration of the observer. Clear? Yes? Yes or no? Siddhi, Chitam, Laksh.
हाँ सर.
Yes, sir.
Okay, so very important. Okay, so now let us do a small, we will see a small this thing problem and try to understand. So there is a lift. I will again explain. There is a lift and there is a mass hanging with the lift. Okay, so obviously there will be a tension and obviously there is a mg and the lift is moving up with acceleration a. Here there is again Siddhi here. Now Siddhi is looking at this lift. Siddhi is standing and building lift is there. Siddhi is looking that this lift is going in acceleration a. Here now here you have Laksh who is standing and seeing the same lift, but inside the lift is standing and there is an acceleration m. Obviously there will be mg and there will be tension. And again the lift is going at a. See, in both the scenarios, in scenario 1 and scenario 2, here the observer is in rest. That means it is a inertial frame. But here Laksh is standing inside the lift and the lift is moving. Both the lift and the mass is moving with same acceleration. Yes? So it is what? It is what? Non-inertial frame. It is non-inertial frame. So let us calculate the, obviously, now when it is moving up, so can we write the equation? So it will be, obviously it is moving up, so T minus mg is equal to ma. Yes or no? T minus, because net force is upward direction, tension is more, so T minus weight equal to the ma. But here T is equal to what? What will this fellow look? What will Laksh will find? Laksh will find what? That this is not moving up. This mass is not moving up. It is stable. So Laksh will feel that there is no net force. So T is equal to only mg. T is equal to only mg. So if you write this one, T will be equal to mg plus ma. But here T is equal to mg. That means in both the scenarios, how can the tension will be equal to mg plus ma, and here it is only mg? That means what happens to this ma here? What happens to the ma here? What happens to the ma here? Yes?
Sir, we should apply pseudo force.
Yes. So in this type of problem, that means it is not wrong. It is only here the Newton's law are no more applicable because it's a non-inertial frame. So what we should do then? What we should do? We should apply pseudo force. Okay. So in this type of problem, we will add pseudo force. So pseudo force will be opposite direction, in this direction. In this direction. When you apply in this direction, your T equal to mg, obviously. So T minus mg minus ma is equal to 0. So your T becomes mg plus ma. Understood? Clear? So if you write that free body diagram, this will look like you have tension upward, mg downward, and your fp downward. So obviously T minus mg minus ma is equal to 0. So T equal to mg plus ma, and then we got the same thing here. Clear? Clear or not?
Yes, sir. Clear, sir.
Siddhi clear? Laksh, Devika,
Hi,
you can chat if you have any issue, please chat and let me know, or else I will understand you are clear.
Yes, sir. Understood, sir.
Superb. So shall we go ahead? Shall we
Sir,
go ahead?
so T
Yeah.
equal to mg plus ma, no, sir?
Yes. T equal to mg plus ma. But there is an issue. Why here ma? What happened to ma? So you have to apply ma downward. Okay. Then it becomes correct. Then this both the equation matches. Understood?
Yes, sir.
Understood? Okay. So pseudo force on the object is always applicable opposite to the observer. Okay, observer looking this side, pseudo force is this side, opposite side. Clear? Clear? Okay. So we will try to understand, very important. So I am trying to explaining in different scenarios. So don't think that we are delaying. Okay. So now there is a car. There is a car. Okay, this is Siddhi's car. Siddhi's car. Siddhi's father is sitting this thing, and Siddhi is happily enjoying here ride. Siddhi, what did she do? She put a pendulum. Car is at rest. Car started moving. Siddhi saw after some time this pendulum was actually like this. Siddhi saying, "Arey, Siddhi's father is riding. Father doesn't know what he's doing." Siddhi saying, "This her pendulum is no more like this. It is like this. It is like this." Understood? Why? Why? Why it is like this? What is actually, that means there is some force which is actually making the pendulum to go backward. What is that? What is that? Can you tell me?
sir, due to acceleration of the car.
Car acceleration. Why car acceleration? Car is moving forward. So what will happen? What is that? What is that? Because you are in the non-inertial frame. You are in a non-inertial frame.
Sir.
Car is moving acceleration. That means here again the pseudo force is coming to picture. So here the pseudo force is actually acting backward, and it is actually acting on the pendulum and making it backward. So more the
Yes,
acceleration, more the pseudo force. So now if the father is going at 100 kilometer per hour, and if he goes 150, the pendulum will become more like this. So faster he moves, so it will become more and more and more, and after some time it will be lying like this. It will be attaching like this. Clear? Able to understand, Pritam?
Yes, sir. Yes, sir. Yes.
Understood? So that means there is a pseudo force which is acting. And what is happening? The pseudo force. So pseudo force is no more in imaginary. We say pseudo force, but pseudo force come into picture when there is a non-inertial frame. And here it can be felt. It can be felt. You can feel it real. There is no more. There is no other force. Your father is not. There is no some demon coming and blowing the pendulum. That means there is really the pendulum is going like this. No spirit is coming. So here the pseudo force acting. More the acceleration. If your A becomes more, the pseudo force will become more. Pritam, clear?
Yes, sir.
Okay. Okay. So now we will try to see how much is the theta, how much it is the inclination. How much is the inclination? How to find? How to find? Now see, when it got inclined, previously it is like this, now it is inclined to like this. So that this is the tension, yes or no? And is the mg, this is the tension and this is the theta. We have to find what is the theta, correct? Now if this is theta, so can we split into the component? This will be what? T cos theta, and this will be T sin theta, correct? Yes or no? Yes or no? Yes or no,
Yes, sir.
Pritam? And the car is moving in this direction, so obviously the mass of the car, into acceleration. So obviously acceleration is this side. Now, now, now what? No. Wait. Sorry. The pseudo force is this side. So now your T cos theta is equal to mg. Obviously this force is negative this force, and your T sin theta is equal to the pseudo force, that is equal to ma. So can we divide both the equation? So T cos theta divided by T sin theta is equal to mg by ma. Yes or no? That means cot theta is equal to what? Equal to what? G by A. Yes or no? Cot theta equal to G by A. Then what is tan theta? A by G. Yes or no? Tan theta is A by G. Then what is theta? The theta will be tan inverse of A by G. That means what it is depending on? It is only depending on the acceleration. More the acceleration, I already told you, if you are going in a lesser speed, a lesser acceleration, then probably it is here. You increase acceleration, it will keep on increasing. The inclination will keep on increasing. So more the acceleration, more the theta, more the FP. Clear? Guys, clear? Pritam, clear?
Sir, can you repeat
Yes, sir.
the
Clear,
last thing
sir.
alone which you told, sir?
Which part? Which part?
The last thing, something you told us, sir, now.
No. I told. So what we saw that tan theta, your inclination is nothing but A by G. G is already a constant for Earth. You are not going to Moon or you are not going to Mars. So these G is a constant. So what it is actually depending on? Acceleration. Acceleration of the car. So if the car goes at a much faster acceleration, then your inclination will become more. That means, it means that if your A is 10, your inclination is something. Maybe it is like this. Now you're increasing, your A becomes 20, your inclination become more. So theta become more. You are still increasing 50, inclination is more. You are still increasing 100, inclination is more. So more the acceleration, more the theta, more the FP.
Yes,
Clear?
sir, understood, sir.
Clear? Fundamentals are clear?
Yes, sir, yes,
Completely?
sir.
Siddhi
Yes, sir.
clear?
Yes, sir.
Laksh, Devika, all of you,
Sir, clear, sir.
pura crystal clear. Okay, no doubt. Very, very important from exam point of view. Okay, so let's do a small problem. Let's do a small problem again, because physics all about problem. Okay, so what is there? There is again a lift. No, there is again a lift. Yeah, there is again a lift. The lift is moving upward, and there is spring balance, and there is again a pulley here. Okay, this is maybe 1.5 kg, and this one is 3 kg. Okay, and the lift is moving at a speed g by 10. That means how much? 1 meter per second square approximately. Yes or no? G is 10, so g by 10 will be how much? 1 meter per second square. Correct or not? So acceleration is 1 meter per second square. Yes or no? Yes? Okay. So now you are told to find out what is the spring balance, because there is a pulley and both are having mass. Obviously the pulley will get elongated. Initially if the spring is like this, the pulley will get elongated. Yes or no? Pulley will get elongated. That means there will be a motion downward direction. But if I told you to solve, find out what is the elongation or how much the spring balance came down, then what you will do? If I told you, you will try to solve from an observer at rest, and it becomes very complicated, because you will be not able to understand how to, because there are so many variables. The lift is moving, this is coming down, this also moves down, so it becomes very difficult to solve from inertial frame. That means in this type of problems, whenever multiple variables, you try to solve from a non-inertial frame. So what? You go inside the lift. You go inside the lift and then you look at the lift. Now, for you, the lift is not moving. For you, the lift is no more moving. It is just that this whole part is that it is something like you are standing and there is a fixed pulley attached and there is a string. So what we are doing, we are replacing the lift with a normal ceiling, and when there is a pulley, and we are replacing the spring with a string, and then we are seeing. Till now clear? Till now clear?
Yes, sir.
Okay. So obviously now let us remove. So now you know very well that whenever the strings are same, tension is same, and this will be 2t. T plus T is 2t. Correct? Yes or no?
Yes, sir.
This is 1.5. This is 3 kg. Now, so let us try to see from the, and you are replacing a spring with a string for temporary sake only. So you are no more, you are removing the spring and putting, just imagine that you are putting a string here. Clear or not? Clear? Obviously this is coming down, whether here or here, both, because 3 kg will come down and 1.5 kg will move up. Yes? And tension will act here, tension will act here. Yes or no? Yes or no?
Yes, sir. Yes, sir.
Huh? Then, so you know very well that we have to apply what? Pseudo force. Pseudo force. That means pseudo force will act like this Fp here. Here also it will act Fp. So let us draw the diagram, actual diagram, free body diagram.
In the 3 kg mass, it will act upwards, sir, pseudo force.
Sorry.
Sir, for the 3 kg mass, the pseudo force will act upwards, sir.
Why? I told you the pseudo force acts opposite to the observer. Opposite to the observer. Where is observer? Observer is here, no? This side,
Yes,
no?
sir.
So pseudo force will
Yes,
act
sir, yes, sir.
downward.
Sir, no, sir. If the 3 kg mass, like, it tends to move down, sir. So the pseudo force will
That
act
is what,
upwards, sir.
Pritam. What did I tell you in the starting? Pseudo force acts opposite to the observer, not to the direction of the object is moving. Observer is this side, looking up this direction. So pseudo force will act downwards. Whether it is moving up or down, the mass, it will not depend. It is depending on observer. So pseudo force will act
Oh, okay, sir.
in both the place downwards. Okay, let us don't get confused. See, definition is important. Try to understand definition. That's why starting I took time. Okay, now if you draw, it will look like one point five three. This will have 1.5 into G. This will have 1.5, sorry, 3 into G. And you have another pseudo force. Pseudo force, Fp equal to Ma. Correct or not? Ma. So 3 into A. Here again 1.5 into A. What is A? What is A? G by 10. Correct or not? This is tension, this is tension. And here it is 2T. Clear? Till now clear, everybody?
Yes, sir. Clear, sir.
So, can we write the equation for this? So 1.5, sorry, T minus 1.5 G minus 1.5 A is equal to 1.5 into A, correct? Correct?
Sir, how did the last 1.5
Array,
A come, sir?
Pritam, this is
No,
moving
sir,
up,
like,
no? This is moving up, beta. This mass is moving
oh,
up.
okay, sir.
The
Yes,
mass
sir,
is
yes, sir.
moving up, say MA, no, F equal to MA. So this is the net force. This is what? The net force. Net force equal to m into acceleration. Mass of the body is 1.5 into acceleration.
Yes,
Now
sir.
for this equation, downwards, it is downwards, correct? Yes or no? That means your T, wait. So 3G plus 3A, yes, minus T equal to downward, right? So 3A, correct? Yes or no? Correct or not? Yes or no? Are yes or no? Pritam?
हाँ sir.
Pritam?
Yes, sir.
Laksh? Pritam?
Yes, sir.
Clear or not?
Yes, sir.
Second equation also correct?
Yes, sir.
So can we combine equation? I'm rubbing this. Okay. So when you add both the equation, obviously T minus T gets cancelled. It becomes 0. So 3G plus 3A minus 1.5G minus 1.5A equal to 1.5A plus 3A. Correct? Yes.
Yes, sir.
So this one. 3 minus 1.5 is 1.5G. 3 minus 1.5 is again 1.5A equal to 1.5A plus 3A. 1.5, 1.5 get cancelled. So how much we got? G. 3A by 1.5 G. So this got 2. So we come 2A by G. Yes? But you know that A equal to G by 10. So can we substitute? A equal to G by 10, and this is again 1 by G. Gets cancelled. So how much we got? 2 by 10. How much we got? 0.2 meter. Oh, I'm sorry. 1.5G equal to 3A, no? So A will be 1.5 by 3. Sorry. A is 1.5 by 3 into G. Correct? Yes? Yes? Hey, did we make any mistake somewhere? Can you just check?
Sir, in the second equation, we can cancel 3 and also, like,
1 minute. Let me just recheck.
yes, sir. I think you made some. Sir, it will be T minus 1.5G minus 1.5A equal to 0 only, no, sir. How, sir? Again, 1.5A came.
Which one?
No, sir. In the first equation, it
Uh,
should be equal to 0 only, no, sir.
why? This is moving up,
Sir,
no?
because Yes, sir.
This is moving up, this is moving down.
Okay, sir. Yes, sir. Yes.
So I think someone made a mistake. The ideally the answer should come. A should be equal to 11 by 3. A should be 11 by 3. Acceleration. Okay. That means acceleration of what? This one. This acceleration. This acceleration. Someone made a mistake. Let me just recheck that. My notes. I did it properly. Okay. So we got 11 by 3. This is the acceleration. Okay. Now, when we got A, can we put it in an equation? Which equation? Any equation of tension. So we will get tension to be what? See, I did a mistake, serious mistake. What mistake? What mistake? Who will tell me I did a mistake? What mistake I did? Can somebody tell what mistake I did? Pritam, can you tell me what mistake I did? See, lift is moving at g by 10. No, lift is moving at g by 10. Correct?
Yes, sir.
So how can I substitute A equal to g by 10? I cannot substitute, no? Lift is moving at g by 10. This is the acceleration of lift. This is the acceleration of lift. So wait, I did my mistake. So let me recorrect. See, we want here to find out the acceleration of what? Acceleration of this one, and this one, both the masses. Then only we can find tension. So correctly, 1.5 g minus 1.5 a equal to 1.5 a. Okay, and here 3g plus 3a minus t is equal to 3a. Correct? So obviously we say 3a, yeah. Mass, yeah. So 3a got cancelled. You are correct. So now tension will also get cancelled. So 1.5, this will come this side. So minus 1.5 g equal to 1.5 a plus 1.5 a, and here this side you will have 3g. Correct? Am I correct now? So here it will become 1.5 g is equal to 3a. Yes or no? Somewhere I am making a mistake. Somewhere I am making a mistake. Okay, guys, see. Now tell me, observer is moving at what acceleration? The lift is moving at g by 10 acceleration. Then what is the acceleration of the observer? What is the acceleration of the observer? G by 10 only, no? Yes or no? Hello? Pritam? Guys, can you hear me?
Yes, sir. Yes.
What is the acceleration of the observer? The lift is moving up. What is the acceleration of the observer? G by 10 only, right?
Yes, sir.
So what did we do mistake? The mistake we did is here it is the acceleration of the observer, and you know that the lift is moving upward. The observer is also moving at g by 10 acceleration. That means this is the acceleration a lift, or so here this a is different than this a. This is the a lift, and here also it is a lift. Clear? Clear? That mistake we are doing. That's why it is not coming. See, anybody who didn't understand, tell me, I will explain again. I did a mistake, so I accept it. Tell me.
So can you explain it again, sir?
Yeah.
Yes, sir. Please explain it again.
I will explain again. Wait. So what we saw that there is a lift and there is a mass. We have to find how much is the reading in the spring balance. Okay. This is 3. This is 1.5. I told you that lift is moving at a velocity, at an acceleration, a lift equal to g by 10. Okay. I told you you cannot solve the problem in the inertial frame, so we have to solve in non-inertial frame. So now think that the lift is not moving, or rather you are seeing basically as a string, and there is a pulley 3 kg, and this is 1.5. Okay, and there is a tension. There is a tension here. This tension is 2t. I am replacing the spring with a string. Okay, and this will go down, this will go up, so we have to find basically the acceleration. Okay, now so I told you whenever you are doing inertial frame, you have to apply a pseudo force. So here mg is there, how much? 3g, 3g, correct? So the pseudo force, I told you what, the mass of the object but the acceleration of the observer. So what is the acceleration of the observer? It is same as the lift, that is equal to g by 10. Clear till now? Clear? So your fp will be what? First this one will be 1.5 into g by 10, and for this one fp will be 3 into g by 10. So it will be what? 1.5 into L, and this will be here 3 into L. Any till now clear? Till now clear? Till now clear? Yes or no?
One second, sir.
Not clear? Pritam,
Yes, sir. One second.
Siddhi, देविका, लक्ष्य समझ में आ रहा है?
Yes, sir. Yes, sir. आ रहा है समझ में.
सिद्धि समझ में आ रहा है? देविका भी गई, नेटवर्क प्रॉब्लम. ओके. So now let us write the equation for this one. So I told you the net force is upward. So T minus, what is the next force? 1.5 G minus 1.5 L equal to how much? 1.5 into A. We have to find A. And the next equation, 3G minus 3G plus 3L minus T is equal to how much? 3A. Correct? Now you know that G by 10 is how much? AL equal to G by 10. Correct? So let us substitute. No, first add the equation. When you add the equation, your TT gets cancelled. So 3G plus 3AL minus 1.5G minus 1.5AL equal to 1.5 plus 3 is 4.5A. Clear? Yes. Yes, Pritam. Yes, Pritam.
Yes, sir.
Okay. So now 3AL minus 1.5L is how much? 1.5L. 3G minus 1.5 is how much? 1.5G equal to 4.5 into A. What is AL? This is G. This is 1.5 into G by 10 equal to 4.5 into A. So this is 1.5 G by 10. This is 1.5 G. So 1.5 G take common. So it will be 1 by 1.510 equal to 4.5 into A. This will be what? 11 by 10 into 1.5 G is equal to 4.5 into A. Then what is A? What is A? 1.5 divided by 4.5 into 11 by 10 into G. Correct? So this is 3. So it is hard. What is A? A is 11 by 30 G. 11 by 30 G. Clear? Clear?
Yes, yes, sir.
Hmm? Yes or no?
Yes, sir.
1.5 G by 10. This is okay. So if you take, so if you multiply, how much it will become? If you multiply, are we sure we got this much? 1.5 into 3 is 4.5. Is it so? No, no, wrong, no. 15 3s are 45, right? Is it so? One plus 1 by 10. So clear? A is equal to this much. Now you got A, right? Now you got A. When you got A, can we find the tension? Can we find the tension? Can we put down the formula and find tension? Yes, we got the tension. Okay, the tension will come. So how much tension will come? This tension, we can find tension, yes. So how much tension will come? So I did the calculation, it is 22 Newton. This tension is 22 Newton. So if 22 Newton is the tension, this is how much? 2 into 22, 44 Newton. Yes or no? So now replace this string with a spring. Replace the string with a spring. Now you know that if the tension is 2T, the spring force also will be equal to 2T. That is equal to 44 Newton. That is equal to 44 Newton. Yes or no? Yes. Yes or no?
Yes, sir.
That's all we have to find. It is telling find the
So
spring
you are
balance.
recording this class now, sir?
Yeah, I'm recording the class. Don't worry. Don't worry. Don't worry. We'll explain. I know because network issue. We'll explain. We'll explain next class. No problem. Okay, many people could not join. I think they got maybe today also for the network issue. I will circulate it. I will circulate some notes also. Don't worry. Okay, I will explain properly, write and also give you the notes. Okay. Okay. Okay, so we'll end the class. Then we will carry on with the other topics, and I will also share you the notes for this. Don't worry, I will share you the notes. Clear?
Thank you, sir.
Okay. Bye. Good night.
Bye, sir.